No, we're not ready to use that yet.
I have no. So I put grams and milligrams. I know that. But like,
Okay, so you're in milligrams. You're in milligrams. You want to turn it into. Let's just build off of what you got. Let's get rid of this here. Look at this.
0.6 milligrams.
Okay. Times. Get rid of.
Milligrams.
Turn it into. Wait. Let's just get the.
Gram.
Okay.
0.001.
Nice. Okay. Now, you could stop and get that number, right? Yep. But there's no need to because we don't need that number.
Can I just keep going?
Yeah, you could just keep going. You want to show them what we're talking about here?
So I could just write what I was going to write with
Yep.
1 mole.
Exactly.
Okay. 1 mole.
Now we're in business. Okay, so let's take a look at this, everybody. You're good job.
Right.
I'm just gonna get rid of this. So look, you still got to know how to do your metric to metrics, right? Because this didn't come out to be the units that we wanted. So again, what are we trying to accomplish here? We're trying to get moles per liter. That's what we're focusing on. And right away we saw we need moles. Well, if I knew I needed moles, I would say, well, I have a mass that gets me to moles. It's 184.6 milligrams, but I got to be in grams. So a gram is 1, milli is 0.001. Remember, we flipped that. And then I would need star grams, was it Carson got that for us? Yeah, Carson got that for us. And so now we could do this calculation, and when we do this, milligrams are going to cancel, grams are going to cancel, and we're in moles now, right? So we've got part of it. We just got to do the calculation to get this. Now we're looking for something else too. And so we'll leave that to Rob Harris to do something productive here.
So if it asks for, like, define concentration, that's the same as molarity?
Molarity is concentration, yep. So you got a couple options of what you could do here, Rob. What do you want to do?
Just going to use the admin.
Sounds good. No. You want liters here, right? You want milliliters down here to cancel, right?
Yeah.
Now wait. What's the meaning of liter? No prefix. Milli means 0.001, so you put milli up there. What's the meaning of liter? One. So that should be, no, that was right. We need 1 on the bottom. We're flipping it. That says that there is 1 milliliter is equal to 1,000th of a liter. That's correct. Yep, there you go. Okay, so check this out. Milliliters is not the unit we want. We want to be in liters. So he starts out with his 500 milliliters. He multiplies it by milliliter on the bottom, so they cancel or reduce to 1. Liter on top. Liter has no prefix. That means 1. It's a base unit. Milli means 0.001. He writes that up top. Multiply across to get 0.5 liters. So we got our liters now. We still need our mole answer there. So we'll give that to Garrett Height. Absolutely.
There's 7 questions after tomorrow, that's it?
Yes. And that first one's just like 3 short ones.
That's the H2O?
Yep. Give me a little number, isn't it? Pretty little, right? 0.1 divided by 200 or 300 almost.
I feel like that's not right.
Should be a pretty small number.
Let's just be,
That seems reasonable. All right, yeah. I mean, I'll double check it, but I was thinking it would be pretty darn small.
0.00.
Or you can write it like that. Either way is fine. So I got 184.6 times 0.001 equals to 294 equals. And I get 0.000627. Is that what you got? Yep,
Yeah,
that's
rounded.
good. That's a perfect place to round to. And then units. Okay. Now, Matt Barry, you want to bring us home?
Do you want me to label the?
I think it's better to do that. Now, I just kind of was looking the other way. I was going to summarize it at the end, but I think that's a good point you're making. Good.
And then paste sticker.
That sounds good. Good. Okay. So just a couple things. One, I think some of you guys have a good plan of attack for these problems, some not as well. That's just what I was hoping. Just was hoping I would do that. Try that again. Hey, it came back. Okay. So my plan attack would be this. Now again, I don't have the original part of the problem here because of the space, but I'll show you that. I'll fix that next problem. It originally said for A, B, and C, calculate the molarity. So as soon as I see calculate the molarity, I probably would have wrote molarity K2CR2O7. I probably would have labeled what I'm calculating the molarity of, because it could be the concentration of a particular ion or all the ions, right? So by first just identifying what it is you're looking for, that's important. So again, then that would mean I'd need moles over liters. And then I would read through and I'd say, well, I've got a mass here. That's just as good as getting moles. And so then I would probably run down this path right now, right? And then I keep reading and I'd say, oh, I got 500 milliliters. Well, that's giving me liters. So I'd run down this path. And then I just plug in. I think it is a good idea, though, to keep that K2CR2O7 with it. So that's a very straightforward calculate molarity problem. Okay, we good here? Okay, so if calculating molarity, you're looking for moles, you're looking for liters, you're looking for moles of whatever it is you're talking about. All right, now let's look at this problem here. Okay, now, again, this cuts off, I understand. It says calculate the concentration of all ions present in the following solutions of strong electrolytes. Okay, now again, the word strong electrolytes here, that just means everything's going to dissociate. Everything's going to break apart. And I want you to do it for just D. So we're calculating the concentration of all ions. So there you go. All right, so if we're calculating concentration of all ions, that's the first thing we need. So why don't we address that? And that'll be for How about John Lupo? If you have to calculate the concentration of all ions, what are you going to write down? Calculate the concentration of all ions.
Would you rate distillation equation?
Even before that, the question says calculate the concentration of all ions. That's what you're being told to do. Last time we wanted to calculate the concentration of K2CR2O7, so we wrote down M equals, right? If you're trying to calculate concentration, what are you calculating? What is concentration? That's not what it's asking for. It's asking for the concentration of all ions, not the concentration of the ammonium sulfate.
Should it just be moles over
Moles of what?
all ions?
Ions, yep. Okay. All right, so Andy Burns, wouldn't it be a day without calling Andy up to the board? All righty, Andy, what can we do now?
Figure out the ions and ammonium sulfate.
You can do that. There should be sheets there, yeah.
Kind of put it over here.
Sure, sure. Now, wouldn't we want to write those next to each other in crisscross?
Oh, yeah.
Wait, what did you do there?
Crisscross, I don't know.
That's not crisscrossing. Crisscrossing says you take the absolute value of the charge and cross them, making them subscripts.
Why would we crisscross?
Because you got to know what the chemical is. And now we can get the number of ions, because unless we crisscross, we don't know how many ions are coming off of there. Now you can either stop there or you can keep moving on with that dissociation there.
Well, there's 3 ions, but I don't really know what to...
Okay, so if you know there's 3 ions by looking at that, that's fine. But do you realize that's going to kill you up here, though?
Yeah.
Right? So how about for just the sake of completeness, you're good. All right, you could answer, you know there's 3 ions. That's important to know. But Bo, can you show us how that would break apart. Yes, Garrett?
So for every concentration of ion problem, we have to crisscross like that?
You're probably